All right, what we're looking at here is we have a rock of mass 2 kilograms that is about 5 meters above ground. Now I'm gonna call this my 0 point right here. I'm gonna call that up or something. Um, and what it comes down to is, well, how fast is it going right before it hits the ground? So right here, right before it hits the ground, how fast is it gonna be going? Now, when you're looking at this, and I'm letting you know this is a conservation of energy problem. That's what we're gonna be talking about. So what it comes down to is, how do you do this? All right, for conservation of energy, we have to talk about the total mechanical energy. And I usually like talking about initial before an event, so right when it's up here, and then after event, after it falls, what's the total mechanical energy? Now we're saying right afterward, right? Now, total mechanical energy is always the same thing. It's always potential energy plus kinetic energy, initial. And a conservation energy set means that, like, whatever energy you have in the beginning is the same energy you have afterwards. It just changes from one form to the other. And you'll see that here. So potential energy final plus kinetic energy final. Now, one thing that I like to do when I'm doing these problems is that if there's any zeros, then I'll go ahead and plug those in. For example, right here, right before it falls, since I know it's not moving, it's like at rest, I know that the initial kinetic energy is 0. And here at the bottom, I already know that right before it hits, and it's not really the greatest picture, but right before it hits, it's lost all its potential energy here. Remember, for you to have potential energy, you need height. And since I'm calling this my 0 point, height would be 0, so potential energy would be 0. And so what I'm left with is the potential energy initial is equal to your kinetic energy final. And at that point, you probably want to be looking up, like, well, how do you find potential energy? There is a slide in the lecture that you'll see. You also find it in your AP Physics 1 equation sheet. Potential energy is, in this case, gravitational potential energy would be mgh. And kinetic energy is defined to be 1/2 mass times velocity squared. A few things you should notice here, that the mass is on both sides. So the mass never changes. And what happens is you could divide the mass and you'll notice that it cancels out. So you can also just cancel it out right there. That's perfectly okay. And so we can just like massage our equation down. Remember, what are we looking for? We're looking for how fast. So I'm looking for the velocity. So that means I have to move that 2. I'm going to multiply both sides by 2. I'll do one side, I won't do another. And I get v squared is equal to 2 times gh. Last thing is, I got to get rid of that. That is a square, yes. Oh, this is a 2. So 2. So I multiply it by 2 on both sides here. 2 times 1/2 cancels this out. And then what you do to one side, I got to do the other. I hope that is a 2 right here. Sorry. Last square, I need to get rid of the square. Remember, rule number 1, you always try the opposite. Opposite of square is square root. What I do to one side, I got to do to the other. And to get your velocity, you have to get the square root of 2 times g times h. So I'm moving this down a little. There you have it. And then you just have to plug stuff in. So v is equal to the square root of 2 times g. I'm going to go ahead and use 10 meters per second squared. And then the height here is 5 meters. And you can prove it to yourself that the units work. So you get 50 times 2 is 100. Ooh, it's not real nice. Real nice number here. Right? It should be 100. And so you get the square root of 100 is 10 meters per second, plus or minus, and then it just depends on how you look at it, right? And that's how you do that, okay?